Okay, so in this video I'm going to go through paper 2 of the higher tier that was originally going to be sat in the summer of 2020. It was eventually sat a little bit later on in that year, but we still call it the summer 2020 series. So you are allowed to use a calculator, so I'll be using my calculator throughout this exam. Okay, so the first one, it says, write 84 as a product of its prime factors. Well, there is a shortcut to do this on your calculator. You can just press shift and then you can just press fact. So if I just clear my calculator for a second, all you do is you type in 84, you press equals, you press shift, and then you press fact, which is above the, if you look at the 8 and then 2 buttons up, you can see the fact button there. And immediately just gives you your answer, which is 2 squared times 3 times 7. Very easy 2 marks there. It then wants you to find the lowest common multiple of 60 and 84. Well, we've already got that 84 is 2 squared times 3 times 7. I'm going to do the same thing with 60 because I think that's going to be quite good to do. So I press 60 equals and then shift fact, and we get 2 squared times 3 times 5. Now there's lots of different ways that you can do this. I do with my students the lowest common multiple. When you think of the lowest common multiple, you ask yourself the question, what wins? In other words, what things have the highest powers? So I'm just going to slightly rewrite this because each number needs to be in its own column. So I have here, the 2's are in their own column, the 3's are in their own column, the 5 and the 7. So the lowest common multiple is what's the highest power in each column. So it would be a 2 squared because they're the same. There'll be a 3. Then the highest one out of the 5 and the blank is a 5, and the highest one out of the blank and the 7 is a 7. So I'm just going to multiply that all together to see what the lowest common multiple is. That is 2 squared times 3 times 5 times 7. So the lowest common multiple is 420. Now there's lots and lots of ways you could do this. You could list out all of the multiples of 60, so you could go 60, 120, 180, etc. You could do that. You could also do this other method that I've used, where you can take 60 and 84, you can divide them by different numbers. So here I'll divide by 2 to give me 30 and 42. I can see they're both in the 6 times table. 30 divided by 6 is 5 and 42 divided by 6 is 7. And then the lowest common multiple is the L shape all multiplied. 2 times 6 times 5 times 7, and you get the same answer. So I've got lots of different methods there, and if you check out the playlist on my homepage, you'll see all the different ways that I answer those lowest common multiple questions. Okay, so we're going to fill in the Venn diagram. It says that the universal set, this very posh E that we've got here, is all the numbers between 1 and 10. A is the even numbers, and B are the factors of 10. We're going to complete the Venn diagram. So I would start off by reminding myself that 2, 4, 6, 8, and 10 are my even numbers. My factors of 10, well, I have 1 times 10 and 2 times 5. So I have 1, 2, 5, and 10. Now the ones that they have in common are the 10 and the 2, so they're going to go in the overlap, this middle section, which then means that the 4, 6 and 8 belong here, and then the 1 and the 5 belong here. And then there are a few numbers that need to go on the outside, because remember, all of them need to be used. So far we've done 1, 2, 4, 5, 6, 8 and 10. So on the outside I also need to put the 3, the 7 and the 9, and you can check you've got them all in there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's a nice 3 marks there. A number is chosen at random from the universal set, so it's being chosen from the universal set. That means it's going to be out of 10, because that's how many there are. And it says it wants to know if they're in the set A and B. Well, the set A and B, that's the intersection, that is the overlap. There are 2 numbers there, so we can just say 2 out of 10. If you want to simplify your answer, you can do to 1 over 5. You could give it as a decimal or percentage, but that's perfectly fine. Okay, question 3. This is a long sort of wordy question, so we'll just make sure we understand what's going on. Carlo puts tins into small boxes and into large boxes. He puts 6 tins into a small and 20 tins into a large. Carlo puts a total of 3,000 tins into boxes, so that the ratio of the tins in small to large is 2 to 3. Well, I actually think there's enough information in these 2 bits here to just do some maths, and that's going to give us some marks to begin with. So we've got 3,000 tins in total, so we want to know how many are small and how many are large. So small to large is 2 to 3, and we have 3,000 in total. Some people like to draw these diagrams, so we've got 2 to 3 for the small and large. Now we've got 3,000 in total, so we're going to divide it by 5 because there are 5 different parts. And 3,000 divided by 5 is 600, so that means each of these parts is 600. So we can very quickly now tell how many small and large there are. So there, for the small, there are 600 tins. There's not 600 tins, there are 1200 tins because there's 2 boxes. And for the large, in our diagram, there's 3 lots of 600, which is 1800 tins. Now I'm actually going to read what the question says. Carlo says that less than 30% of the boxes filled with tins are large boxes. Okay, so we now need to think about the boxes that are being filled, not these boxes, but the boxes that are being filled with tins. So there are 6 tins in each small box. So the number of small boxes is going to be the 1200 divided by 6, which of course we can do on a calculator if we're feeling lazy and we want to check it. So there's 200 small boxes. And then for the number of large boxes, we're going to do our 1800, and there are 20 per box. So I'll do 1800 divided by 20, which is 90. So there are 90 large boxes. And Carlo says that less than 30% of the boxes filled are large. So it looks like we're filling up in total. We are filling 290 boxes in total. And the large ones are 90. So I'm going to do 90 out of 290. And I'm going to make that become a percentage by multiplying it by 100. And we'll then see what the answer is. So we're going to do 90 out of 290. And I'm going to multiply that by 100. I'm going to press SD. And so actually 31.0% are large boxes. And he said less than 30%. So Carlos is wrong. Or Carlo, not Carlos, is wrong. Okay. I've just given that rounded, but it's obviously bigger than 30%, so you don't need to worry about that too much. Okay, complete the table of values for y equals 5 minus x cubed. Now, there's actually a feature on your calculator that can do this. It might look a bit different to mine, but you go to mode, and then you put it in table mode, and then you type in the function. So I'm going to type in 5 minus x cubed. You get x by doing alpha, and then the bracket. 5 minus x cubed, and I will do my cubed button, which is here. You then press equals. Sometimes it will ask if you want a second function, which is g of x, and you just press equals again. It then asks where it wants you to start. So we want to start ours at -2, and we want it to finish at 2. So I press 2, and we want the step to be 1. It then gives you this table that you've got here, and for the table you can see that the outputs are 13, 6, 5, 4, and -3. I'm looking at the second column where it says f of x, so really easy to do that on your calculator. On the grid below, draw the graph from -2 to 2. Now it's going to be a smooth graph when we draw this, so the -2 is going to go with 13, which is up here, the -1 goes with 6, the 0 goes with 5, 1 goes with 4, and 2 goes with -3. So all that's left to do now is to try and draw this with a smooth curve. They're pretty lenient with this, it just must be smooth rather than like dot to dot. It doesn't matter if it's perfect, it just needs to look something like that to get those 2 extra marks. Okay, question 5, this is a trigonometry question because we've got 2 sides and we've got an angle. We're going to try and work out the value of x. Well, let's label the different sides that we've got here. This is definitely the hypotenuse and this side is the opposite. So if we think about our options of SOHCAHTOA, we don't label all the sides, we just label the ones that we have and the ones that we need. Looks like we're going to be doing sine here. So we can see that the sine of the angle, which is 34, is equal to the opposite, which is x, divided by the hypotenuse, which is 178. So all we need to do to solve this is multiply by 178 on both sides. So 178 multiplied by the sine of 34. We'll just type that in our calculator and that will be our answer. So let me just quickly go back to the other mode that I have. Okay, so I'm going to do 178 multiplied by the sine of 34, and it wants it to 1 decimal place, so that's going to be 99.5. So the answer is 99.5 millimeters. Okay, that was question 5. Let's have a look at question 6 now, and question 6 is a vectors kind of question that we have. So it says 2a minus 3b. Find 2a minus 3b as a column vector. So 2a minus 3b, nice and easy. It's going to be 2 multiplied by 3, 4, minus 3 multiplied by 5 minus 2. Well, you can just double these things, so you'll get 6, 8. And then I'm going to multiply these by 3. So I'm going to keep the minus outside, but I'm going to multiply by 3, so I get minus 15 and minus 6. Just have to be really careful here. I'll do 6 minus 15, and then 8 minus 6. And you can put this on your calculator if you just want to make sure that you're getting it right. So we'll do the 6 minus 15. Great, that's minus 9, and then 8 minus 6 is 14. So it's minus 9, 14. Try and do as much on a calculator as you can do so that you're not making any silly mistakes like positives and negatives and stuff. The diagram shows a right angle triangle and a quarter circle. As soon as I see right angle triangle, I always think of either Pythagoras or I think of trigonometry. And a quarter circle, okay. The right angle triangle has an angle ABC as 90. Great, I can see that here, so that's not that useful. The quarter circle has center C and radius CB. Well, I mean, that's pretty obvious, really, so that's kind of a bit of a waste of space, really. Work out the area of the quarter circle. Give your answer correct to 3 significant figures. Well, if you're going to try and find the area of a circle, it's normally pi r squared. But because we want a quarter circle, we're going to do a quarter pi r squared. So I think the thing that's missing here is we need to find the radius. So the radius is actually this side, which looks like it's something to do with this triangle. So it is, in fact, a Pythagoras question. If I just do a quick sketch of that first triangle that we have there, I'm going to just put on the other side. So we have a 9 here and we have a 6. I'm going to try and find this length that we've got over here. I'm going to use the letter r because it's actually going to be the radius of the other one. Now, the quickest way to do this is it's going to be the square root of the hypotenuse squared minus the other side squared. So it's going to be the square root of 9 squared minus 6 squared. If you did the longer method, you could say that r squared plus 6 squared equals 9 squared from Pythagoras. R squared equals 9 squared minus 6 squared, and r is the square root of 9 squared minus 6 squared. But you can actually just go straight to this if you do a lot of practice with Pythagoras. So we'll find out what the radius is. It's going to be the square root of 9 squared minus 6 squared. So let's just get here, syntax error. It's going to be the square root of 9 squared minus 6 squared. So that's 3 root 5, or we'll just leave it as 3 root 5 for now, actually, why not? And so then we're going to find out the area of the quarter circle. We've already said that's going to be a quarter multiplied by pi multiplied by r squared. So I've already got that stored on my calculator there as the answer. So I'm going to do a quarter multiplied by pi, which you get with shift and then the answer at the bottom button next to the answer. And I'm going to multiply that by the answer that I have on my calculator, the 3 root 5 that's here. I'm just going to press answer squared to save a bit of time. And it wants it to 3 significant figures, so I'm just going to write down 35.3 meters squared. And that's to 3 significant figures there. It's just the first 3 figures that we have. It's all in meters, so we can say that it's 35.3 meters squared. Okay, question 8 that we have here. Tarek buys a laptop. He gets a discount of 5% off the normal price. He pays £551 for the laptop. Work out the normal price. So we have the normal price, and then that gets discounted to give us the discount price. And the normal price is the thing that we're going to try and find out. The discount price is £551. Now, if you wanted to reduce something by 5%, think to yourself what you would multiply it by. Most of you should be able to tell me you multiply it by 0.95. So if we want to go backwards, there are loads of ways of doing this. This is just the way I do this. If you want to go backwards, you do the opposite and you divide it by 0.95. So I'm just actually going to do that with single calculation. I'm going to do 551 divided by 0.95, and that's just going to give me the normal price. So 551 divided by 0.95 looks like the original price of the laptop is £580. Now I'm just going to very quickly show you another way that people like to do this. Sometimes people say, oh well, it's 95%, it's been reduced by that amount, so I'll say 551. They'll find out 1% by dividing it by 95, and then they'll times that by 100. I'll show you it's going to give you the same thing. If you do 551 divided by 95 and then times it by 100, you do end up with the same thing of £580. You just need to decide what method works best for you. I like this. This topic that we have here, if you want to look at it in more detail, is called reverse percentages. It's where you're going backwards with percentages. Joan invests £6,000 in a savings account. The savings account pays compound interest at a rate of 2.4% for the first year and 1.7% for each extra year, and she's going to do it after 3 years. So that means we're going to have one of these ones, and then this one is going to happen twice for the second and the third year. I'm actually going to write this is the first year, and then this is the second and the third. So she's got £6,000 to begin with, and it's going to increase by 2.4%. So it's 100%, and it's going to increase by 2.4%. That is 102.4%. 102.4% as a decimal, you can literally type in 102.4%, and it gives it to you as a decimal. You divide it by 100. So that's 1.024. So we're going to multiply it by 1.024, and then we're going to take that, and we're going to find out what 1.7% is. So I'll do 101.7%, and that is 1.107. It's 1.017, and because that's happening for 2 years, we square that. So I'm just going to do the calculation of 6,000 multiplied by 1.024 multiplied by 1.017 squared. And we're going to get that the value of the investment is £6,354.67. Now you could do that as separate calculations, but it is a lot more work. So I think you'll find this is the best way to do this for compound interest. Okay, Aisha recorded the heights in centimetres of some girls. She used her results to work out the information in this table. Let's look at that in a second. Aisha drew this box plot for the information in the table, but the box plot is not fully correct. Write down the 2 things that Aisha should do to make the box plot fully correct. So I kind of think about this as like, what would a teacher do? I'd like mark it and actually see what's happened. So let's look at the least height and see if it is correct. So it's 142 centimetres, which she's drawn here. Yeah, actually I think that is 142 centimetres, so that is correct. The lower quartile is 154, which is here. Yep, that's in the right place, so that's good. Now the interquartile range is how wide the whole box is. It needs to be 17. Or you could think to yourself that the interquartile range, 17, is the upper quartile, take away the lower quartile. So the upper quartile must be 17 bigger than the lower quartile. So I'm going to do 17 plus 154. Let's see if the upper quartile is in the right place. So I'm going to do 17 plus 154. It's 171. So the upper quartile should be at 171, but she's drawn it here at 172. So let's actually do that first one. The upper quartile should be at 172. Should be at, 171, not 172. Let's check the rest. So the median is 162. Nope, she's drawn it at 161, so she's put it in the wrong place. The median should be at 161. At 162 is me saying it the wrong way again. The median should be at 162. She put it at 161, so she's plotted it at the wrong place. And the upper quartile should be at 171, not 172. It's good to say what's wrong and how they should correct it. Okay, question 10. We've got simplifying this expression to the power of 0. Well, anything to the power of 0 is 1. This one we're not going to complicate this too much. We can just see that there is an 8 minus 4 and an 8 minus 4 squared. So you can actually just cancel an x minus 4 with a squared there. So we just end up with 8 over x minus 4. If you think about it, I don't know, if it was like 8a over a squared, you can see how you could do the a with the squared to get 8 over a. It's the same thing, it's just got a bracketed expression instead. Okay, we're going to simplify this. Each part is going to be cubed. So we're going to start off with 3 cubed. Why do anything non-calculator? You can just do it on here. So you get 3 cubed is 27. Nice bit for the start. Then you're going to do the powers multiplied. So you're going to do n to the power of 4 times 3. That's n to the power of 12. And you're going to do w squared to the power of 3, which means multiply them. So you get w to the power of 6. Okay, Jack is in a restaurant. There are 5 starters, 8 mains, and some desserts on the menu. He's going to choose 1 starter, 1 main course, and 1 dessert. He says there are 240 ways he can choose his starter, his main, and his dessert. Could he be correct? So the way you do this is you would normally take the number of starters, the number of main courses, and the number of desserts. You would multiply them together, and that would tell you how many options there are. So starters, mains, desserts. I've used the letter D because we don't know how many desserts. And Jack thinks there are 240. So let's just see if this would work. I'm going to do the 240. Well, in fact, I can just say this 5 times 8 times D. That's 40D equals 240. So let's just check. Let's do 240 divided by 40. Yes, so actually there could be 6 desserts. So could Jack be correct? Yes, he could be. He could be. There could be 6 desserts. Now the reason it's saying this is because if you got something that was not a whole number, then it wouldn't. You wouldn't be able to do this. It would only work if it's a whole number. If it was a decimal, obviously that's not something that is gonna. That's not gonna work. Okay, you couldn't have like 3.5 desserts on a menu. Okay, question 12 that we've got here. Question 12 says this graph gives information about the volume of petrol in the tank of Jim's car after it has travelled a distance of d kilometres. So the further he's travelling, the less petrol there is in his car. So we're going to try and find the gradient of the graph. The gradient is the letter m. It's the change in the y-axis, or in this case, this v-axis, divided by the change over here. So this difference that we've got on the side, you can see this value is 27, and it's actually going down 27. So I know it's going to be negative overall, because you can see that the gradient of this line is going downwards. And then along the bottom, it is 300. So this is 27. This is 300 along the bottom, so the gradient is the change in this direction divided by this. It's the rise divided by the run. So I'm just going to do my minus 27 divided by 300. So we get the answer minus 0.09. You don't always need to do it on the dotted line. I'm just being over the top. Okay, so it says interpret what the gradient of the graph represents. So now we need to go back to what the question was even talking about. It's saying about the amount of volume of petrol in the tank and how far he drives. So the gradient in this case is actually going to say for every single mile that we're going across here, how much the petrol is decreasing in its volume. So the minus 0.09 that we're going to get here is going to be something like the amount of petrol used per kilometre. So the gradient of this graph represents the amount of petrol used per kilometre. And that's because the gradient says for each 1 square that you move in the x direction, or in this case the d kilometers direction, how much is the volume changing? Now it's not going to be 1 square, but it's 1 unit. How much is it decreasing by? Okay, here is a triangle ABC. It is not a right angle, so we won't be doing Pythagoras. It says work out the length of AB that we've got here. So this is the one that I am trying to look for. I'm just going to call this X because that's a nice letter to use with this. Hopefully we might be able to spot that we have got X and we've got an angle that's opposite it over here. And then I've got this one, which is 23.8. I need to know the angle that is opposite. Well, I can find that because that means that I can then do the sine rule. The sine rule is when you have an angle and a side and another angle. So I can find out this red one because the angles inside a triangle must add to 180. So I'll take away 36 and I'll take away 24. So this angle is 120. So I'm going to do the sine rule, where I'm going to do the side length, which is x, divided by the sine of the angle opposite, which is sine 34. That would be the same as the side length, which is 23.8, divided by the sine of the angle that is opposite. So all I'm going to do to get x as the subject to solve the equation is I'm going to take the 23.8 divided by the sine of 120, and I'm just going to multiply it by the sine of 34, and I'm going to input that all into my calculator exactly as it is there. So it's 23.8 over sine 120, and then I'm going to multiply that by the sine of 34, which gives me that x is equal to 15.4 centimetres to 1 decimal place, so 15.4 centimeters. And just kind of like looking at the diagram, although it's not necessarily drawn to scale, it seems like a reasonable length. It's not like 100, it's not like 2. It's somewhere that would kind of work with that kind of triangle that we've got there. Okay, question 14. Here are two squares A and B. The length of each side of square B is 4 centimeters greater than the length of each side of square A. Well, like immediately, I'm going to say if this one had a length of x on all sides, then this one is going to have something that is 4 greater. So that's x plus 4 and x plus 4. It then says that the area of square B is 70 centimeters squared greater than the area of square A. Well, let's just quickly work these out. So the area of A is just going to be the length times the width, x times x, which is x squared. And the area of square B, well, it's going to be x plus 4 multiplied by, so you don't need to put that multiplication sign, x plus 4 times x plus 4. Expand those brackets, we get x squared, we get 4x, we get 4x, and we get 16. So that's x squared plus 8x plus 16. So we know that the area of B, which is x squared plus 8x plus 16, is the same as the area of square B. It's this area that we've got here, but it's got an extra 70 as well. So the area of square A that it's equal to is x squared, but it is 70 bigger than the area of this one, okay? So what I'm going to do now is solve this equation. I can take away x squared from both sides, they cancel out, which leaves me with 8x plus 16 equals 70. I haven't even read what the question is. I often do these things because you just think, let's just do some maths. So I'm going to do 70 take away 16 to try and solve the equation. So 8x is equal to 54. And then I'm going to divide by 8 to find out what it is. Whoops, let's press equals, and then I'll do the answer divided by 8. So x is equal to 6.75. Now let's read what the question wants. It wants us to find the area of square B. Give your answer correct to 3 significant figures. So it's 6.75 is what x is. So this is going to be 6.75 plus 4 for one of the sides. So I'll do 6.75 plus 4. That means each side of this square B is 10.75. So the area of square B is 10.75 multiplied by 10.75, or 10.75 squared, which is 115.5625, but it wanted it to 3 significant figures. So that means I'm going to write it, here's my 3 significant figures, that 5 is going to make it change to 116. So the answer is 116 centimeters squared. Okay, question 15. It is a shape question, and it says, describe fully the single transformation that maps triangle A to triangle B. So this is the starting one. This is the one where it ends up. It ends up over here. So it looks like they've changed size. So there's a single transformation. The only one that allows them to change size is enlargement. So I'm definitely going to write down that it's an enlargement. But there are 3 things that you need to say. One, that it's an enlargement. Then we need to say what the center of the enlargement is. And then we need to say what the scale factor is. Now, to find the center, you join up the same corners together. So I'm going to start off with this kind of obvious corner, which is the one that's by the right angle. You join them up using a ruler. Luckily, my thing kind of automatically does it. And then I'm going to see which ones match. Now, I actually think this one here is going to match with this one here. And then in a different color, in this black color, I'll do these 2 top corners. So I'm going to do that top corner with this top corner, or bottom corner down here. And what we do is we see where they cross over, and that tells you the center of enlargement. So this point here is the center of enlargement, and that coordinate is 1, 1. Now we're going to work out what the scale factor is. The scale factor, let's just concentrate on one point. I'm going to concentrate on this point that was here, which in actual fact, yeah, I did do that in red. That one has changed to this point. So from the center of enlargement, we're going 2 right and 2 up. And looks like to go to the new shape, we're actually going 3 left and then 3 down. So the fact that we've gone from right and up to left and down is immediately telling me that the scale factor is definitely going to be negative. Negative meaning going in the other direction. So previously we were going 2 right, we're now going 3 left. So to find out what that scale factor is, I can do 3 divided by 2 to see that that's what I'm multiplying to. If I do 2 and I multiply it by minus 1.5, 2 multiplied by minus 1.5, I get minus 3, which means go in this direction. If I do 2 multiplied by minus 3, it means go in the opposite direction from the centre of enlargement. So we're looking for enlargement, centre 1, 1, scale factor minus 1.5. Okay, question 16. Here are the first 5 terms of a quadratic sequence. Find an expression in terms of n for the nth term. So I teach this particular method that I really like, and you can always check out the full playlist on my homepage if you want to see how this works. But for a quadratic, you have to find out the first difference and the second difference. Clearly that's going up 11, that's then going up 17. I'm going to be lazy and I'm going to check what this one is. So I'm going to do 61 take away 38, it's going up 23, and I'll do 90 take away 61, that's 29. Now you do the second difference as well. So that's going up 6, that's going up 6, and that's going up 6. So what you need to know for this one is 2a, this one is 3a plus b, and this one is a plus b plus c. And when I say a, b, and c, I'm talking about a quadratic sequence is an squared plus bn plus c. This a, this b, and this c. I explain why this works, but you might want to go and check that out for a full explanation for this. So the easiest one is to deal with the bottom one, so that's 2a is equal to 6, meaning that a is equal to 3. Great. We then have that 3a plus b is equal to 11. So 3a, that's 3 times, so that's 9 plus b is 11. So b is 11, take away 9, which is 2. And then our last one, a plus b plus c is equal to 10. So that's a plus b plus c is equal to 10. That looks like c is going to be equal to 5 for that to work. So it's going to be our an squared plus bn plus c. That's going to be 3n squared plus 2n plus 5 is the answer to this question. Now you can actually check this one. If I just quickly go to the calculator for a second, I'm going to go back to table mode. And I'm going to input my function, which is going to be 3n squared plus 2n plus 5, but I'm going to have to do it as x. So I'm going to do 3x squared plus 2x, alpha with x, plus 5. I'm going to start it at 1, and there are 5 terms here, so I'm going to end it at 5, and I'll go up in ones. And you can see I've got 10, 21, 38, 61, and 90, so I've definitely answered it correctly. Okay, it says write down the coordinates of the turning point of this graph. The turning point is on a graph when it looks something like where it's moving, where it's changing like that, okay? It looks like, what you should just know how to do this one, but the x value is when this thing here is equal to 0, so it's minus 12, and the y value is this part, which is minus 7. So because we have x plus 12 squared minus 7, we want this to be as as small as possible. This thing here, the smallest thing that it can ever be is 0, because when you square something it always becomes 0 or greater than 0. So that occurs when x is minus 12, and when this thing is 0, the overall thing is minus 7. Okay, question 18. This is where things are starting to get a bit harder because they need you to do a little bit more in the question. It says the diagram represents a solid cone, and they've told you what the surface area of a cone is, the curved surface area, not the bottom part. The cone has a base diameter of 20 and a slant height of 25. A circle is drawn around the surface of the cone at a slant height of 10 centimeters above the base. The curved surface of the cone above the circle is painted grey. So this section up here, which immediately we know is 15 centimeters, because obviously this is the same as this section is being painted grey. Work out the area of the curved surface area of the cone that is not painted grey. So we want this kind of bottom section. Give your answer as a multiple of pi. You must show all your working. So I think to be able to get that kind of bottom section, we're going to do the surface of the large cone, and we'll take away the surface of the small cone, and that should give us that kind of grey, the white section that's at the bottom. So that's going to be the pattern that we're going to try and do here. So let's do the large cone. Switch back to my blue. So the large cone is going to be this formula. It says pi RL, so pi multiplied by, well, the radius. This is the diameter of the circle. So for the large cone, I think it's pretty obvious that the radius is 10 centimeters. So we're going to do pi times 10 times by L, and it's the large cone we're talking about, so it's this 25 that we've got here. Don't need a calculator because it wants it in terms of pi. That's 250 pi. Now the small cone is where things get a bit trickier, because for the small cone, if I just draw the triangle that's from the cone, I'm going to just draw like this bit here. The small cone has, this side is 15, and we don't actually know what the radius is. That's the thing we want to find out. The big cone, right? We knew that it was 25 on the side and 10 along the bottom. So how are we going to figure out what this radius is on the bottom? Well, hopefully we can spot these are similar triangles, because these angles are the same because it's the same triangle. These angles are the same. That must mean that these angles are the same as well. So we can do some similar triangles with these bits that we've got here. I'm going to just grab that diagram and put it with the large, and then I'm going to put the small one down here. So for the small one, looks like there's a relationship. We're going to think, how have we gone from the 25 to the 15? And we're going to do the same thing for the bottom part. So to go from, in fact, why don't we do it the other way around? Why don't we say, how do we go from 15 to 25? What do we multiply by? No, we are going to go this way. 25 to 15, we're going to do 15 divided by 25. Let's go back to my normal calculation. 15 divided by 25 is 0.6. So to go from here to here, I've multiplied by 0.6. So to go from the 10 to the radius, I'm also going to multiply by 0.6. And 10 times 0.6 is 6. So on this triangle at the bottom, we now know that it is 6 centimeters here. It's getting a bit messy. Let's tidy this. So it is 6 centimeters. So by going back up to this diagram, we now know that the radius is 6 centimeters. So I've got the pi, I've got the radius is 6, and I've got that the length is 15. So for the small cone, I can do pi multiplied by the radius, which was 6, and the curved part here. So I'm going to do the 6 times 15 just to check it. It's 90, so it's 90 pi. So the bit that we want, the not painted grey, so the unpainted is going to be our 250 pi minus 90 pi. You can ignore the pi's when you do this. You could type them in if you want to. I'll show you that you can. 250 pi minus 90 pi. Press SD, and we get 160 pi for the answer of this, 160 pi. Okay, we are very nearly there. I think we've only got a few questions left, 19, 20, 21 and 22. A hot air balloon is descending, meaning it's going down. The height of the balloon n minutes after it starts to descend is hn meters. The height of the balloon n plus 1 minutes after it starts to descend, hn plus 1 meters, is given by this formula. Now this looks scary, but it's not scary. It says the balloon starts to descend from a height of 1,200 meters at 9:15. At 9:16, the height of the balloon is 1,040 meters. Work out the height of the balloon at 9:18. Okay, well, let's just see what's going on. Let's just go back through this. So it says that it starts to descend from a height of this at 9:15. So it looks like when it starts, we could say then that h1, the starting time that we've got, is 1,200. Now this formula tells you how to use it, really. So to find out what h2 is, you do k and you multiply it by the previous height, which is h1, and then you add 20. And we've already been told what h2 is. We've been told that 1 minute later it's at 1,040. So h2 must be 1,040. So 1,040 is equal to k multiplied by the previous height, which is 1,200, plus 20. We're going to try and find out what k is equal to. So I'm going to do 1,040 subtract 20, that's 1,020. That's k multiplied by 1,200. So K, I'll do 1020. Whoops, what's going on with my calculator? I'm going to do 1020 divided by 1200, so that K is 0.85. So now we've got what the formula is. The formula now says that to find the next one, hn plus 1, you do 0.85 times the previous one plus 20. Oh, the previous one I should have said is hn plus 20. So we have at 915, we have 916, 917, and 918 is the one that we want. So it started off at 1200. It then went to 1040. Let's find out the next one. So h3 will be 0.85 times h2 plus 20. That's 0.85 times by 1040 plus 20. 0.85 times 1040 plus 20, that is 904. And so our last one, our fourth one, is going to be 0.85 times h3, the previous one, plus 20. You don't need to do as much working out as I've done here. In fact, I'm going to show you a shortcut in a second. Times it by the previous one and add 20. So I'm going to do 0.85 times 904 plus 20, and we get 788.4, which is our answer. But I'm just going to write it here for the sake of completing this as well. Okay, so we get 788.4. Now, if you wanted to do this on your calculator quicker, you can actually just do this formula straight away. So you can input into your calculator the starting number, which is 1200, and then you can just make the formula, which is 0.85 of the answer plus 20. That then gives you the next one. You can just press equals, and then you can press equals again, and it will give you the 904. Then you can press it again, and it gives you the 788.4. That was at 918. This would be 919, 920, 921, etc. And you can see what will happen over time is the hot air balloon is going to get lower and lower. At least I think it's a hot air balloon. So I just make this up, a hot air balloon. Okay, we are nearly there. It says there are only red sweets and yellow sweets in a bag. There are n red sweets and there are 8 yellow sweets in the bag. So in total, as soon as I read this, I think, okay, well, in total, we have n plus 8 in total. Sajid is going to take at random a sweet from the bag and eat it. He says that the probability that the sweet will be red is 7 over 10. Show why the probability cannot be red. Well, the probability that it's red, if he wanted to pick a red one, there are n red ones out of a total of n plus 8. And he says that this is equal to 7/10. So to solve this equation, let's find out what n is and see if it's going to be reasonable. You're going to send the n plus 8 up over here and the 10 up over here. So we get 10n equals 7 multiplied by n plus 8. 10n is 7n plus 8 times 7, which is 56. I'll subtract the 7n, so 3n is 56, and so n is 56 over 3, and 56 over 3 is not a whole number, it is 18.666, and you can't have 18.6 reds, so n is not a whole number or not an integer, so the probability can't be 7/10. Because it doesn't make any sense to say that there are 18.6 red sweets. It doesn't work. So after Sajid has taken the first sweet from the bag and eating it, he's going to take at random a second sweet from the bag. Given that the probability that both sweets he takes will be red is 3 over 5, work out the number of red sweets in the bag. So first of all, when he picks a sweet, he's going to do n over n plus 8. That's the probability of picking a red the first time. Now we're going to multiply it by the probability that he picks a red the second time. Well, however many reds there were before, he's now eaten one of them, so there's now one less. And however many sweets there were in total in the bag, he's eaten one of them, so there is one less. So you'll notice both the top and the bottom have decreased by 1 because one of them has been eaten. And we've been told that this probability is 3/5. So I'm going to do quite a lot of working out here. In fact, I know this is going to take up a lot of space. Does it have a spare page for me? Yes, it does, so I don't even need to worry too much. This is a big question. This is a 5 marker, okay? So we're going to actually do some multiplication. I'm going to put brackets to remind us that when we do these, we have to expand really carefully. So we get n brackets n minus 1 over n plus 8, n plus 7, and that's equal to 3/5. So just like here when I sent these things up to the other side like this, I can do that same thing over here. I'm going to send the 5 up there, and I'm going to send that double bracket up there. So we get 5n n minus 1 equals 3, which is still there, n plus 8, n plus 7. Now I'm going to do some bracket expanding. 5n times n is 5n squared, 5n minus 1 is 5n. I'm just going to do this bit of the brackets first, and then I'll deal with the 3 afterwards. So it's going to be n squared plus 8n plus, what have I done? No, I'm going to do that in a slightly different order, just because of the way I usually do it. N squared plus 7n plus 8n plus 56. Let's simplify. So it's 5n squared minus 5n. That's 3 brackets n squared plus 15n plus 56. And I'm going to continue on this next page. I'm going to expand that 3 brackets. That's 3n squared. 15 times 3, you can check on your calculator, is 45. And 56 times 3 is 100. And me checking it because I'm being lazy, 168. Now this is the quadratic that we've got here. And we're going to try and find out the number of red sweets in the bag. We're trying to find out what is n equal to. So I need to make a quadratic always equal to 0. So I'm going to put everything to the left so that the equals 0 is over here. So I'll do 5n squared take away 3n squared. That's 2n squared that we have for this part, okay? Then we're going to do the minus 5n minus 45. Minus 5 minus 45, minus 5 minus 45, minus 50 it's going to be. So that's minus 50n. And then we're going to also subtract the 168 that we have, okay? So now that we've got to this stage, we can see if we can actually simplify this. We actually can simplify this because everything can be divided by 2. So I'm going to get n squared minus 25n. Half of 168 is 84. Again, you can check that on your calculator. Now, I know that this is not going to be the quadratic formula because n needs to be an integer, and so I don't need to go to that length. This is definitely going to be able to factorize. So I'm going to think about the number 84 and what numbers multiply to give 84, and then I'm going to find them that add to minus 25. Well, it could be 1 and 84, but it's not that. It could be 2 and 42. Let's see if 3 goes into 84. So I'll do 84 divided by 3. Oh, it's 28. So I actually think we can see it's going to be this one, right? If I make one of these positive and one of them negative, I can make it work. If I make this one negative and this one positive, then they will multiply to minus 84, but add to minus 25. So it's going to be an n plus 3 and an n minus 28 to be equal to 0. So either n is minus 3, or n is 28, but it doesn't make sense to have minus 3 reds, so the answer is that there are 28 red sweets. Okay, nearly there. The graph of the curve with equation y equals f of x is shown on the grid below. On the grid above, sketch the graph of the curve with equation y equals f of minus x. Now what this means to do is to reflect it in the y-axis. It means to do kind of like a horizontal flipping like this. So I'm going to see the points that are the same. That point's going to stay there. This point is going to move over here. This point will move here. This point will move here. And this point will move here. So it's going to come up. It's then going to kind of smoothly come down like this. And then it's going to join up here. So it's been reflected in the y-axis. The curve C with equation y equals 5 plus 2x minus x squared is transformed by a translation to give the curve S, such that the point 1, 6 is mapped to the point 4, 6 on S. So it looks like all that's happened is the x coordinate has had 3 added to it. Find an equation for S. So this original function, if you have something that is f of x, and if it moves 3 spaces to the right, it's unfortunately not f of x plus 3. It's kind of the opposite. It is actually f of x minus 3. And you can check out my full playlist on this for how this works, because this is a tricky topic and I'd like you to learn it fully, really. So we're actually going to say that we're going to find f of x minus 3. Now f of x, in this case, is 5 plus 2x minus x squared. We know that is going to be f of x minus 3 because it's moving 3 spaces to the right from curve C to curve S. So this means that anywhere that you see an x, you're now going to replace it with an x minus 3. So it is going to be 5 plus 2 brackets x minus 3 minus x minus 3 squared. So the equation for x, it still has to, for s, sorry, still has to have a y at the beginning, is going to be 5 plus 2 brackets x minus 3 minus x minus 3 squared. And you don't need to do any simplifying to that. It is perfectly fine just to kind of leave it in that form that it's actually in. Okay? We are now on to the last question, I think. Is this the last question? Yes, it is. We're going to move on to this last question, which is to do with circles. And it says that the circle C has the centre at the origin. The tangent to C passes through the points minus 20, 0 and 0, 10. Work out an equation of C. You must show all your working. Now, there's lots and lots of different ways to do this, but I'm going to just go with the way that I think makes sense to me. So they've told me that there is a tangent and it crosses at these two coordinates, minus 20, 0, which is going to be somewhere over here, and then 0, 10, which is somewhere over here. And this is going to be the tangent to the circle that goes through those 2 points. Now the circle has got the centre at the origin. You're going to find these diagrams make it way easier to sort of figure out what's going on. Now that's obviously a terribly drawn circle and I didn't even have the right tool on here. That's not too bad. So I'm going to try and find out the equation of this circle. Now the equation of the circle is this: x squared plus y squared equals r squared. So all I need to do is find out the radius that I have of this circle. Lots of different ways to do this. This is just the way that my brain sees this. I'm going to begin by remembering that the tangent and the radius meet at 90 degrees. So if I have a look at this line that I've got here, I'll call it the line. I'm going to see if I can work out the gradient of the line. So the gradient of that line is going to be the change in y, which you can see here is clearly 10, divided by the change in x, which is 20. So it's 10 divided by 20, which is a half. So for this line that we've got here, let's call that one L2. I can find out its gradient because it's perpendicular. So you take the negative reciprocal of a half. You take the negative reciprocal of a half, which is minus 2. So there's lots of different ways that you could do this. I think this is how my brain sees this. I want to find out this point here because then I can find out the length of the radius. Well, that point is where line 1, and if I extended line 2, it's where those two lines cross over. So let's go back to line 1 for a second. We know that the equation of that line is going to be y equals mx plus c. And the y-intercept, you can see why it's the last question by the way, can't you? It's 10. So that one is that. And for line 2, because the gradient is minus 2, it's going to be y equals mx plus c. Well, that line, its y-intercept is 0. So it's just y equals minus 2x. Now I'm going to find out where these cross over. So to find out where they cross over, I'm going to solve them simultaneously, which means I can just make this part equal this part. So I get a half x plus 10 equals minus 2x. So I'm going to do the half plus 2. Half plus 2, that's 2.5x. And I'll subtract the 10. So I'll do minus 10 divided by 2.5. Which is minus 4. So that means that the x coordinate here is minus 4. Now I can find out what the y coordinate is. So the y coordinate using this one is minus 2 multiplied by the x coordinate, which is minus 4, which is 8. So this is 8. Now looking at this triangle, we know that this part of the triangle is 8, this part of the triangle is 4, so I can do Pythagoras to find out the radius. So I'm going to draw that little red triangle that I had here. We had an 8 and a 4, and this is the radius. So we know that the radius squared is 4 squared plus 8 squared. That's all I need to find out for the equation. I just needed to find out what the radius squared is. So I'll do 4 squared plus 8 squared, 4 squared plus 8 squared, which is 80. So the radius squared is 80, meaning that the equation of the circle is x squared plus y squared is equal to 80. A very challenging last question. If you like this kind of thing though, this is exactly what A-level maths is going to be like. Okay, so I will keep doing these if people are finding them useful. Do go and check out my full page, because I've got loads more playlists of actually like teaching you these things. This is me just doing the questions, right? If you need these things explained in more detail, you can go and actually find out about this whole topic and how it works, rather than me just showing you one question, because showing you one question isn't really going to be enough for you to learn it. So do subscribe if you think this is going to be useful for you, so you can keep up to date with all of my uploads, and just wishing you the best of luck with all your studies.